Equilibrium in physical processes. Reactions in nature often do not reach completion. In most reactions, two or more substances react to form products which themselves react to give back the original substances. Sometimes, two opposing processes take place at equal rates and there is no net change in composition. For example, in a saturated solution, a solute is added to a solvent and the system reaches a point at which the rate of dissolution is equal to the rate at which the dissolved solute crystallizes. We say that system has reached equilibrium state. Phase transformation processes. Solid-liquid equilibrium. If we keep ice and water mixture in a perfectly insulated thermos flask at 273 K, we observe that the mass of ice and water do not change with time and the temperature inside the flask remains constant. Molecules from the liquid water collide against ice and stick to it, and some molecules of ice go into liquid phase. There is no change of mass of ice and water. Ice and water remain in dynamic equilibrium only at particular temperature and pressure. Liquid-vapor equilibrium. If we take a liquid in a closed container, the molecules with relatively higher kinetic energy escape the liquid surface into the vapor phase. The molecules from the vapor phase strike the liquid surface and are changed to the liquid phase. Vapor molecules condense to the liquid state at the same rate at which liquid molecules vaporize. We say that the system has reached equilibrium state at this stage. We may represent it as H2O, liquid in equilibrium with water vapor. This is a dynamic equilibrium because the molecules exchange phases at the same rate and the pressure exerted by the vapor remains constant with time. Solid-vapor equilibrium. If we place solid iodine in a closed vessel, we observe that the vessel gradually gets filled up with violet vapor and the intensity of color increases with time. After some time, the density of violet vapor becomes constant and equilibrium is reached. At this stage, solid iodine sublimes to give iodine vapor at the same rate at which the iodine vapor condenses to give solid iodine. The equilibrium can be represented as I2 solid in equilibrium, I2 vapor, reversible reaction. Other examples of similar type of equilibrium are camphor solid in equilibrium, camphor vapor, NH4Cl solid in equilibrium, NH4Cl vapor. Gases in liquids. In a soda water bottle, there is equilibrium between the molecules in the gaseous state and the molecules dissolved in the liquid under pressure, that is, CO2 gas in equilibrium, CO2 in solution. This equilibrium is governed by Henry's law, which states that the mass of a gas dissolved in a given mass of a solvent at any temperature is proportional to the pressure of the gas above the solvent. General characteristics of equilibria involving physical processes. 1. Equilibrium is possible only in a closed system at a given temperature. 2. Both the opposing processes occur at the same rate and there is a dynamic but stable condition. 3. All measurable properties of the system remain constant. 4. When equilibrium is attained for a physical process, it is characterized by constant value of one of its parameters at a given temperature.